Welcome to today's lesson on classifying matter. For today's lesson, you'll need a copy of the Classifying Matter Guided Notes. Good luck. By the end of this lesson, you should be able to describe and classify pure substances as elements or compounds, and describe and classify mixtures as being either heterogeneous or homogeneous. And you should be able to classify mixtures as solutions, suspensions, or colloids. The vocabulary for today's lesson is pure substance, element, atom, compound, heterogeneous mixture, homogeneous mixture, solution, suspension, and colloid. A pure substance is matter that always has exactly the same composition. Table salt and sugar are two examples of pure substances. Every pinch of salt tastes equally salty, and every teaspoon of sugar tastes equally sweet. Every sample of a given substance has the same properties because the substance has a fixed, uniform composition. Substances can be classified into two categories, either elements or compounds. An element is a substance that cannot be broken down into simpler substances. Imagine tearing a piece of aluminum foil into smaller and smaller pieces. Eventually, you would end up with extremely tiny particles called aluminum atoms. An atom is the smallest particle of an element. An element has a fixed composition because it contains only one type of atom. And no two elements contain the same type of atom. So a carbon atom is a carbon atom, a gold atom is a gold atom, aluminum atom is an aluminum atom. Examples of elements. Most elements are solid at room temperature. Examples of elements that are solid at room temperature are shown at the right. From the top down, we have carbon. Now both of these are made from carbon. The top is diamond and it is being held up by graphite. Both are made of carbon. One is used in pencils to write with, and the other is used to make jewelry. The difference between the two elements is that the minerals were formed under different circumstances. Diamonds are minerals that are formed under extremely high heat and pressure in the Earth's crust during its formation. Below that, we have a sample of gold, and then on the bottom we have an element called aluminum, which we make pop cans out of, aluminum foil, most of which we are very familiar with. Some are gas at room temperature, like oxygen and nitrogen. But only two are liquid at room temperature, bromine and mercury. These are the only two elements that are liquid at room temperature, and they also have to meet very hazardous materials. Water is composed of the elements hydrogen and oxygen. When electricity passes through the water, bubbles of oxygen and hydrogen gas form to rise to the surface of the water. If the gases are collected and a flame is brought near the mixture, the gas and the oxygen will react and turn into water. Water is classified as a compound. A compound is that made up of two or more simpler substances that can be broken down into those simpler substances. Properties of a compound differ from that of substances they made. A compound always contains two or more elements joined in a fixed proportion. Concept check number 1. Question 1. Why does every sample of a given substance have the same properties? Question 2. Explain why composition of an element is fixed. Question 3. Describe the composition of a compound. This would be a great time to pause the video, answer the questions, and then resume play. Question 1. Why does every sample of a given substance have the same properties? The properties are the same because the composition of the substance does not vary. Question 2. Explain why the composition of an element is fixed. An element contains only one atom. Question 3. Describe the composition of a compound. A compound contains two or more elements that are joined in a fixed proportion. Suppose you are making salsa. You have a choice. You can use the exact amount of ingredients listed in the recipe, or you can adjust the ingredients to your taste. The properties of a mixture can vary because the composition of a mixture is not fixed. The type of pepper and the quantity of pepper used in salsa determines the hotness of a batch of salsa. Chili peppers contain a compound called capsaicin. This is what causes that hotness of the salsa. Now, the amounts of capsaicin vary in different peppers. For instance, chili peppers are more hot than a jalapeno pepper. My personal favorite is habanero. But no matter how well you stir the batch, the ingredients will not be evenly distributed. There may be, for example, more onion in one portion of the salsa than another. Mixtures can be classified by how well parts of the mixtures are distributed throughout the mixture. If you look at a handful of sand, it appears to be of all the same material. But if you look closer at it, you can see that sand is not the same throughout. You can notice the grains have different sizes, some are light, some are dark. This is an example of a heterogeneous mixture. A heterogeneous mixture is a type of mixture in which the parts of the mixture are noticeably different from one another. Here are two items that we should be familiar with. We have dish soap and we have a cup of coffee. We would expect something out of each of these items. The first, the dish soap, should be able to clean the dishes whether we use the first drop or the last drop of soap in the container. It should be the same. And the second, the cup of coffee should taste the same whether it's the first sip or the last sip. And that is because both examples are substances that are the same throughout. These are said to be homogeneous mixtures. A homogeneous mixture is a type of mixture in which the substances are so evenly distributed that it is difficult to distinguish one substance from another. Concept check number 2. Compare and contrast between heterogeneous mixtures and homogeneous mixtures. This would be a great time to pause the video, answer the question, and then resume. Question 1. Compare and contrast between heterogeneous mixtures and homogeneous mixtures. In heterogeneous mixtures, the parts are noticeably different from one another, and in a homogeneous mixture, the parts appear to be the same throughout. It isn't always easy to tell a homogeneous mixture from a heterogeneous mixture. You may need to observe the properties of the mixture before you can decide. The size of the particles in a mixture has an effect of the properties on the mixture. Based on the size of its largest particles, a mixture can be classified as a solution, a suspension, or a colloid. If you place a spoonful of sugar in a glass of hot water, the result is a homogeneous mixture of sugar and water. This mixture is known as a solution. A solution is a mixture that forms when substances dissolve and form a homogeneous mixture. Many items we use on a daily basis might just have the instructions, shake well before using. This is a good indicator that these products are suspensions. A suspension is a heterogeneous mixture that separates into layers over time. Milk is a mixture of substances including water, sugar, proteins, and fats. When fresh cow milk is allowed to stand, a layer of cream rises to the top. This layer contains much of the fat in the milk. This layer of cream is skimmed off the top and used to make other dairy products such as butter. Now, you may be thinking, but Mr. Herdigan, the milk in my fridge doesn't have a layer on top of that fatty cream stuff. Well, Unless you have milking cows and you get your milk straight from the cow, then you probably bought it at the store. In which case, the milk was processed so that the fat remains dispersed throughout the milk. The result? Homogenized milk. A colloid contains some particles that are intermediate size between the small particles in a solution and the large particles in a suspension. Colloids do not separate into layers like suspensions do. Concept check number 3. Question 1. Why can the properties of a mixture vary? Question 2. On what basis can mixtures be classified as solutions, suspensions, or colloids? This would be a good time to pause the video, answer the questions, and then return. So question 1. Why can the properties of a mixture vary? Because the composition of a mixture is not set. Question 2. On what basis can mixtures be classified as solutions, suspensions, or colloids? Mixtures can be classified as solutions, suspensions, or colloids based on the size of their largest particle.